Alright guys, today we're going to talk about surface areas and volumes of similar figures. This is one of the tougher lessons for a lot of people. So, similar solids are solids that have the same shape and proportional corresponding dimensions. Okay, so here's the thing. I have three cylinders here. Which cylinder is similar to cylinder A? So here's cylinder A. They're all cylinders, okay? Are they the same shape? Well, it's kind of hard to tell. So the first thing that we got to do is we have to look at the proportions of the sides, okay? So we have here proportion, the height to the radius is 4 to 6, okay? So we're going to go height to radius would be 3 to 5 on this one. And so I have a proportion here, and now what I would do is I would do the means extremes property. So if these two proportions are equal, then these two multiplied together will equal these two multiplied together. All right, so 3 times 6 should equal 5 times 4, and that's 18 equals 20. Okay, so that's not true. So these are not proportional, okay? So these would not be similar. Now they're close to being similar because these two numbers are the same, but they're not similar. So let's check the next one. So we would have, again, 4 to 6, and that should equal 5 to 7.5. Okay, let's see how this does. So this would mean that 4 times 7.5 should equal 5 times 6. Well, this is easy. That's 30. 4 times 7 is 28, and 4 times a half would be 2, so this is also 30. Okay? This tells me that these are proportional to these, and so cylinder C is the one that's similar to cylinder A, because it's got all the same proportions. Okay? So there we go. Alright, so the cones here are similar. Find the missing slant height L. So we can make a proportion of the radius to the height would be 5 to 13. And I would also go radius to height over here would be 7 to L. And then I would solve this, so L would always, remember you always take the two diagonal numbers and multiply those two together, so this would be 13 times 7, and you divide by the other number. Okay, so let's see, 13 times 7, that's going to be 20, that's 91 over 5. Okay, so what? That goes in there. 18 and 1/5. So this is 18.2 yards. You could put 91/5 and it would be right. It's just, it's not the best answer. Most people would rather talk about 18.2 yards. Now, I don't have to arrange them that way, so I did radius to slant height. I could have arranged them as radius to radius and slant height to slant height. So that would have been 5 over 7 equals 13 over L. 5 is to 7 is 13 is to L. Now if you look, why do you get to do it a different way? Because that's obviously different than this. But if you look at it, you multiply the two diagonal numbers, that's 7 times 13, and then you divide by 5. This is the same thing this was, and so I'm going to get the same answer. L is going to be 18.2 again. So, there you go. Okay, here's a big theorem, and you need to know this one. When two solids are similar with a scale factor of x, the ratio of their surface areas is x squared, and the ratio of their volumes is x cubed. Okay, this is one that you want to know this one. Always. Okay, this will come in hugely handy. Okay, so these two pyramids are similar. What is the surface area of pyramid A? Okay, so the first thing you need to do is calculate the scale factor. So I find two edges or pieces of length that are related to each other. And so the scale factor will be 6 to 10, or 3/5. Okay? So for every 3 on this pyramid, you have 5 on this pyramid. Okay, next, since I want to find surface area, I go back here. Surface area has a ratio of x squared. So here I have a surface area of 600 square feet, and here's my scale factor. So I'm going to take 3/5 squared will equal something, I don't know what this one is, over 600. And I need to solve this. So this is going to be 9/25 equals x over 600. And so x is going to be 9 times 600 divided by 25. Okay, so that's going to be 5,400 on the top and 25 on the bottom. Let's see, that's going to be 25 is going to go into each 100 4 times, and there's 5,400, so that's just going to be, let's see, 54 times 4. Sorry, I went brain dead there for a second. So it's going to be 216. Alright, so there's my surface area. This is going to be 216 square feet on the smaller one. And always check, is the smaller one got the smaller surface area? Because it's really easy to flip these over and get it wrong. Okay? So, if the scale factor is A to B, then the surface areas are going to be A squared to B squared, and the volumes are going to be A cubed to B cubed. Okay, so you do these two. The solids are similar. Find the surface area of the red solid. Show your answer to the nearest tenth. So I'll let you pause the video here, do these, and then jump back on and see how you did. Okay, so the first thing you want to do here on this one is you want to get the scale factor. So the scale factor is going to be 5 to 8. Now it doesn't matter if you get 5 to 8 or 8 to 5, as long as you get the surface area in the right place. Okay, now, since it's surface area, the ratio is going to be 5/8 squared, or 25/64. Okay, now, this is the bigger one, so 25 over 64 is going to equal, this is the big one, it's got to go on the bottom with the other big one. It's going to be x. And now I really wish I had my calculator right here, because this is going to be a tough one to do. So x is going to be 608 times 25 divided by 64. So let's get out our calculator app here real quick. And we'll just figure this out here. So 608 times 25 is 15,200 divided by 64. So this is 237.5. So x is going to be 237.5, and this is going to be in square meters. Okay. So hopefully you got that. Now this one here, this one, the scale factor, I'm going to relate the diameters. So the scale factor is going to be 4 to 5, which means the scale factor between the surface areas is going to be 4/5 squared, or 16/25. Okay, I've got the big one on the bottom. So the big one is going to be the red one on this one. That's going to be X, and the small one is going to be 110. Okay, so now X is going to be 110 times 25 divided by 16. So let's get out our calculator app again. I'm sorry, what was that? 110 times 25 divided by 16. 110 times 25 divided by 16. It's going to be 171.875. And that's going to be in square centimeters. Okay, so that should be purple. There we go. Oops. What just happened? There we go. So hopefully you got both those right. Okay, these solids are similar. Find the volume of the red solid. So now we're looking at volume. So again, we're going to get our scale factor. The scale factor is going to be 5 to 12. Now these questions are volume, so it's going to be 5/12 cubed. So that's going to be 125 on the top, and I think that's 1728 on the bottom. Let's double check here. So this would be 12 times 12 times 12. 1728, yep. Okay. So, now this is going to equal, let's see, this is the volume of the bigger one, is 288. Here's the bigger one on the bottom, so it's going to go on the bottom. And then we got to figure out the top here. So X is going to be 125 times 288 divided by 1,728. Definitely a calculator question. Okay, so 125 times 288 is 36,000 divided by 1728. 20.83 repeating. Oops. Okay, so okay, that's going to be in cubic centimeters. Again, always double check. The smaller cone has the smaller volume, and it's a lot smaller. You got to remember, when you take something like this and you multiply it by itself 3 times, it's going to shrink really quickly. Okay, these solids are similar. Find the volume of the red solid. So I'll let you do this one on your own, and then jump back on and see how you did. Okay, on this one, the scale factor is going to equal 4 to 3. So the volume scale factor is going to be 4/3 cubed, which is going to be 64 over 27. Okay, we're going to set up a proportion, and the smaller box is the smaller numbers on the bottom here, so the smaller number is going to go here. That's going to be X, and so X is going to be 64 times 9 divided by 27. So let's get out our calculator. 64 times 9 divided by 27 is 21.3 repeating. So X is going to be 21.3 repeating, and that's going to be in cubic inches. Okay, let's kind of look at why this happens here. Real quick, kind of an aside. You know, why does it get so much bigger with volume? Here's the thing. Let's say I got 1 cubic block here. It's 1 by 1 by 1. So it's its edge is 1. Its surface area is 6, because it's 1 and there's 6 faces on this thing, so 1 times 6. Okay, its volume is just 1. Okay? 1 cubic unit. This is 6 square units, and this is 1 unit. Okay, now let's say we double the size of this thing. So it's now 2 by 2 by 2. It's twice as big. Okay, 2 by 2 by 2. So its edge is now 2 units. It got twice as big. Okay, what happened to its surface area? Well, its surface area didn't get twice as big because the surface area was 6. This side is 4. This side is 4. There's 6 sides, they're all 4. So 6 times 4 is 24. The surface area is now 24 square units. You got to remember, it doubled this way and it doubled this way. So 2 times 2 is 4. Okay, now let's look what happened to the volume. Okay, the volume is the length times the width times the height. 2 times 2 times 2, that's 8. 8 cubic units. So, the scale factor is 2 to 1. The surface area is 24 to 6, which is now 4 to 1, which just happens to be 2 squared, right? And then the volume is 8 to 1, which just happens to be 2 cubed. And that's because it got twice as big, twice as high, and twice as long. Okay. So the dimensions of the touch tank at the aquarium are doubled. What is the volume of the new touch tank? Okay, so this is just like we did with this cube right down here. Okay, it doubled its size. Okay, the dimensions are doubled, so its length and width and height are all twice as big. All right, that means that the scale factor then is 2, which means the new volume, the ratio of the volumes is now, instead of being 2 to 1, it's now 8 to 1. It's 2 cubed to 1 cubed. So we set this up. This is the smaller one, this is the larger one. This is the smaller one, it's 2,000. What's the bigger one? So we solve this by x is 8 times 2,000 divided by 1, which is 16,000 cubic feet. Okay, you're going to get to do problems 1 through 21 odd. I will see you guys in class.